We're going to put into practice a lot of algebra, and we're going to look at some theorems and proofs, and we're going to pick up the pace here as we end out chapter 2. Take a look at an important theorem that we'll use a lot called the right angles congruence theorem. I'm going to abbreviate that all right angles are congruent. I'm just going to say what the theorem is. When I write this in a proof, I'm going to say all right angles are congruent. I know Nelson is thinking, well, duh, kind of like reflexive or symmetric. Everybody knows that. But in math, we don't take anything for granted. The reason we know this is true is because the proof below. Take a look. We have two right angles, and we're going to prove that they're congruent. Given that angle 1 and angle 2 are right angles, I know their measures are 90 degrees by definition of right angle. I disagree with the book on the property they wrote here. If the measure of angle 1 equals 90 and the measure of angle 2 equals 90, then measure of angle 1 equals measure of angle 2 by substitution. And then, because the measures are equal, the angles are congruent. It is a 4-step proof. It's short, and we'll never have to write that proof again, because now we all know that all right angles are congruent. And you can just say that anytime you want to use it. All right angles are congruent. And if you know you have two right angles, you can conclude that all right angles are congruent. If this is the hypothesis, this is the conclusion. If this, then that. Good? Another important theorem that we use a lot that kids don't remember, but it shows up and it's so useful when you remember it, are the supplements theorem. I'm not going to say congruent, just supplements theorem and the complements theorem. If you read them, they seem obvious. They seem like we should know that this makes sense. We will prove the supplements theorem in class, but it says if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So given that 1 and 2 are supplementary, given that 2 and 3 are supplementary, I can conclude that 1 and 3 are congruent. The complements theorem is just the same except talking about complementary angles. Given 4 and 5 are complementary, given 6 and 5 are complementary, then 4 is congruent to 6. These are beautiful theorems. If I were you, I would write them down in my yellow notebook because you will see them in the most unique places, and it can make your life really easy if you remember them. The next theorem is not a theorem according to our book, and I completely disagree. We are not going to call this a postulate. We're actually going to prove it right now. If two angles form a linear pair, then they're supplementary. I don't know why the book decides to call this a postulate. I think it's lazy. I think it's easy to prove given definitions that they've given us in the book. So let's take an example here. Angle 1 and angle 2 are a linear pair. I'm going to prove this quickly, and I should not be as sloppy. So given that they're a linear pair, all right, then that means here, let me write some things here. Here's 1 and here's 2. We've got a linear pair. I'm going to put some points on here. I'm going to call this A. I'm going to call this B. I'm going to call this C. I'm going to call this D. And the reason I can do that, if I want to be really particular, add points A, B, C, and D. I think we have a postulate that says a line contains at least 2 points. And there's a corollary that says it contains more than 2. So there we go. We've got our 2. Got our 2 on this one. Got our 2 here. So I'm okay with that. Or 2 lines intersect at 1 point. So I'm good with that, right? There's a couple postulates we could say for those points. Now I'm going to say that ray AB ray BA and ray BD are opposite rays. Sorry, that's over here. Are opposite rays. And the reason for that is definition of linear pair. The definition of linear pair says the non-shared sides are opposite rays. The next thing I'm going to say is ray BA and ray BD form a straight line. And that is definition of opposite rays. That's in the book. I just looked it up to make sure I could say that. Opposite rays form a straight line. The next thing I can say is that angle ABD, the measure of that angle is 180 degrees. And that's definition of a straight angle. Our book defines a straight angle, which I disagree with, but they do, and they say it has a measure of 180 degrees. That's the definition. So now we have a straight line, we know it's 180 degrees. Now I can say the measure of angle ABD is equal to the measure of angle ABC plus the measure of angle DBC. And the reason for that? Angle addition postulate. Now the last thing I can say is that the measure of angle ABC plus the measure of angle DBC is equal to, and I should put it over here, 180. And that is substitution. And I'm going to be real lazy here because my wife is calling me and I need to call her back. I could flip that with symmetric. I could replace measure of ABC with angle 1, and I could replace measure of angle DBC with the measure of angle 2. And then I've started with a linear pair, and I've proven that their measures add up to 180. So then I can say those measures are supplementary. Definition of supplementary. Do you see why I disagree with the book calling this a postulate? This seems like something we can prove. Sorry about that. I'm actually going to type up a formal proof of the linear pair theorem. We will use it all the time. Linear pair theorem. If two angles are a linear pair, then they're supplementary. If those angles are supplementary, then their measures are 180. We're going to use it all the time. We're actually going to use it when you prove this theorem, that vertical angles are congruent, that angle 1 and angle 3 are congruent, that angle 2 and angle 4 are congruent. And it goes pretty quick. Here's one way to do it. Angle 1 and angle 2 are a linear pair. Definition of linear pair. Angle 2 and angle 3 are a linear pair. Definition of linear pair. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Right? This angle is congruent to this angle. This angle is supplementary to this angle. This angle is supplementary to this angle. These two angles are congruent by the supplements theorem. They're supplementary to the same angle. Therefore, they're congruent. So you can see there is a place where that supplements theorem comes in. Vertical angles are congruent. When I use that in a proof, I usually call it VAT for vertical angle theorem. You could even just write this, vertical angles are congruent. You can abbreviate vert, angs are congruent. I really like this for congruent as opposed to C. So start using that symbol. I will give you a list of approved abbreviations shortly. So that is this last lesson in chapter or in unit 2. You will be using these theorems and postulates in proofs in class, but you'll also be doing some algebra with those. So you'll be given a linear pair and you'll know they add up to 180, so you can solve for x and things like that. Hope you have a good night. I will get you formal write-ups of proofs and more proof practice. Peace.